Today we are going to talk about tensors. Tensors are a data structure in PyTorch that basically allow you to perform massive computations on massive array-like structures. So let's dive into a little bit about what a tensor is and how we can use them. So according to the PyTorch documentation, a torch tensor is a multidimensional matrix containing elements of a single data type. So what is a data type? A data type is a float or an integer. Torch actually has a bunch of data types that you can use for these tensors. So you can have a 32-bit float, 64-bit float, depending on the precision that you need. You can have integers. You can even have bools. And these are some of the different data types that you can use for your torch tensors. By default, by default, the torch tensor is a float, a 32-bit float. We'll see that in a minute. But it's good to kind of familiarize yourself with a tensor and what it is before you start digging deep into PyTorch. If you use NumPy before, NumPy is a way that you can represent array-like structures in multi-dimensional arrays. This is pretty similar, but Torch has their own library and their own tensors to deal with these array-like structures. And so we'll be talking a little bit more about it. And yeah, let's dive in. So constructing tensors, there's definitely a couple ways that you can make tensors. So the first one that we are going to do is torch tensor. Um, and let's take a look at the documentation here. So a torch tensor, this function right here, constructs a tensor with no autograd history. I'll talk a little bit about autograd in a later video, but for right now, just understand that tensor is with no autograd history is just a regular tensor. And what we said before, a tensor is a multi-dimensional array. It could be just one. It could just be one-dimensional. It could be two-dimensional, three, four, and so on. It could be n-dimensional. So if we use this torch tensor here, we just pass in data and data type and a few other ones that we won't worry about right now. We'll just mainly focus on passing in data and specifying a type if we need it. It looks like we have data type of none as default, but it should be float 32 when we type it in. You can change the default, and that's why it says none here. But let's start playing with it. So we have a torch tensor, um, and we can have an array here. So we can have 1, 2, 3, and we go. I forgot to import torch. It looks like it still remembers that I'm using torch. That's why that worked. But let's definitely import that. So we got torch tensor 1, 2, 3, and we get a tensor. Pretty simple, right? Let's see if we can maybe do a two-dimensional array. So try 1, 2, 3. 1, 2, 3. We got to make sure we got to have brackets in here, though. It's not going to like that. All right. So we got some integers here. Let's see what the type is of this actually. Let's say .dtype, and we have got int64. So the default here was int64 because we typed in integers. Let's say we typed in integers, but we actually wanted floats. We'd actually change that with that dtype parameter. So we can say dtype equals torch.float32. And now we should get some floats. So we got those little decimal points there. That means we've got floats. We could check it if we wanted to. We do have float 32. So those are some ways that you can create some tensors. Let's see if we could do a tensor with just a single number. Kind of play with this a little bit. Yep, we can. Just a single number that's a one-dimensional array. I definitely think that could be useful in some places. Let's say we want to, let's try and break this. Let's see if we have one array here and then our second array and our two-dimensional array isn't quite the same. Well, length. I bet this is going to throw an error. And it does throw an error. Expected sequence of length 3 at dim1. So this is expecting 3 elements right here. So if we add another element in this second array, we should get it and it should work. Great. So we can assign a variable to it if we want and use it later. I've just been doing it like this to make it easy for us right now. So let's see the second way that you can make tensors. We could use torch ones. You could say torch.ones, and say 2, 3, and we've got a bunch of ones. So let's take a look a little bit at this documentation. I don't know what those balloons were earlier. If you're wondering about that, I honestly have no idea. Maybe you didn't see the balloons. Let me know in the comments. So we have torch ones right here. It returns a tensor filled with a scalar value 1 with the shape defined by the variable argument size. So we can basically create torch tensors with a and just specify some number, and it'll create a huge tensor for us with the number that we specified, the size. So let's go back to here to this example. Let's just say we want to do torch ones 6. This should give us 6 ones. When we get 6 ones here, let's say we want to do 6, 2, and we have a 6 by 2 array. Let's see if we can make this 3-dimensional. Now we got 3 dimensions here. Let's add maybe a 4th dimension, but make this crazy, do 20. That is definitely getting bigger for a tensor, but it may seem like a big tensor, but it's not even close to what we'll be dealing with in PyTorch. So besides torch ones, we could also do torch zeros. So we can maybe have 5 zeros, and it is the same as torch ones, except zeros. Let's see. We've got tensor filled with the scalar value 0 with the shape defined by the variable argument size. We can also specify the D type here. So we can change that type. Let's say we want to do ints. Doesn't like int. Maybe int 64. Oh, I gotta specify D type. There we go. And we can say .d type, and we get a torch int 64. Okay. So one last way that we can construct tensors is by using the rand function. So we can say torch.rand. Let's take a look at that documentation before we go ahead and jump into it. So we got torch rand returns a tensor filled with random numbers from a uniform distribution on the interval 0 to 1. And we can include 0, but we don't include 1, which is interesting. The shape of the tensor is defined by the variable argument size. So we kind of initialize it in the same way that we have the size here. And so I think it'll be interesting that we can create multiple dimensional arrays, all with values between 0 and 1. So let's test this out. Let's say we got torch.rand 5. So this should give us 5 elements with random numbers between 0s and 1s. Let's look at this. So we got a bunch of 0s and a bunch of 1s. This looks good to me. Let's see if we can make this a 2-dimensional array. All right, now we got something here. 2 dimensions, 5 by 2, each between 0 and 1. Nice. So let's see if we can play with this a little bit. What would happen? Never tried this before. I think it'd be interesting to specify that we want an int and see what happens. Is it going to give us all 0s? torch 64. Doesn't quite like that. Let's see if we can put that in there. Maybe we can't do that. Interesting. It says we can have the dtype parameter. Am I doing something wrong here? Tort. Maybe we can try int 32. No, I guess it doesn't like it. What happens if we try just like a double or a let's look back at our types that we do again. Torch tensor. We can do a float 32. Let's try torch. Let's just try this one right here and see what happens. I guess that works. Let's see, what was I doing wrong with integers? So I was trying torch int. This is the one I tried, torch int 64. Was I doing something wrong with that? Let's try it out. It doesn't like that. Maybe you can't do that for torch.rand. I'm not sure why you can't use an integer. Since we do get values between 0 and 1, it wouldn't really make sense to why we would want to have integers, because all of these would just be zeros, so why not just use torch.zeros? But if you do know any ideas on that, let me know down in the comments, and we'll talk about it. That's about it. That's all I have for you today. Please stay tuned for some later videos that we're going to have on tensors.